Hello, hello, hello. Can you all hear me? What's going on, people? Okay, I'm just doing my usual checks. Make sure everything's looking good, sounding good. Do I come through okay? Not too loud, not too quiet. Don't have tea, but a lovely mango milkshake. Hey, that could be worse, for sure. Hey, Smittix, Wolf, Splat. Thanks as always for tagging along. It's been a while, hasn't it? I think it's been close to 2 weeks since the last time I streamed. But a lot's happened along those lines. I've been to the USA and back in that time. Went over and hung out with the lovely Rapid 7 folks during the Metasploit hackathon. Got to put some faces to names that I feel like I've known for ages but hadn't met, and hooked up again with a bunch of folks that I haven't seen for ages whose faces I had missed. So that was really cool, and there's some pretty fun and crazy features coming out of that. One of which I'm going to end up having to implement in the CLR Meterpreter that we're working on now, but more on that down the track. So that's kind of why I've been away, and there's been a little bit of jet lag and work interfering with the streaming schedule, but I'm hoping that is all done and dusted and will no longer interfere. So we'll try and get back to a regular programming of live streams, at least for this project. And as I mentioned on the twits a bit earlier on, I do have a plan on doing 2, if not more, non sort of CLR Meterp related streams, back in the debugging and CTFing and all that sort of stuff. So hopefully that'll keep people entertained. So that's coming soon. But for now, I'm going to bash out another one of these CLR Meterpreter streams. So as always, feel free to ask questions along the way, and I will do my best to answer them as we go. For those who are probably already wondering, we are using what would it be? We are using Monstercat Gold. Ooh, what's going on? Barney of the Rubble has resubscribed to one for 2. Holy moly, dude. You've got to stop this. You're throwing so much money via Twitch. It's unbelievable. But thank you, Barney. Very kind of you, mate. It is very much appreciated. He was gifting everyone subs, wasn't he? Crazy, crazy boy. So, anyway, back to normal programming. Tea. Gaiakuro again this evening. Very lovely green. You are definitely top on Patreon as well. Like I said, you got to stop throwing money at this stuff, man. It's going to cost you the earth. So you are number one. You are definitely number one. You are number one across the board, except for in cheering. But that's not a challenge, so don't go and throw more money at stuff, because that's unnecessary. So... And I just had another subscriber, Gonathu, Twitch Prime subscription. Thank you very much for that. Very much appreciated. Cheers to you. Hopefully you're drinking tea, just like I am. Oh, I haven't had one of these for a couple of days. So tasty. And also we're going to have some dark choc. 90%, as always. Thankfully, there's only 2 pieces left in this particular bar, which is a good thing. Otherwise, I might inhale way more than is good for me. So, with our chocolate and our tea in place, let's get stuck in. Now, I hope you will like my new thingy up there, which I'm going to transport myself to now. We are in the This Is Fine burning room, which I think is fitting for so many reasons. So we might stay in this room for the foreseeable future. Okay, now, in case you don't remember where we left off last, we're at a point where we'd built a standard API and we were looking to sort of handle the staging process and the plugin loading process. And that's kind of where we got to. So let's have a quick gander. Remember what we were able to get to here was we had a load lib function. We'd implemented that at a fairly rudimentary level here. We were taking the bytes out of the assembly, and we were loading it into the current app domain. And then from there, we were trying to enumerate the plugins that are inside that. And for each one of these plugins, which we assume there's only one, we try to create an instance of it, and then we try and register the plugin with ourselves. Now, the problem we had last time is that assembly resolving wasn't working, and that's the first thing that we're going to fix. So in order to demonstrate this issue, let's remember I got MSF console. Oops. MSF console. Oh, that's right. I've deleted my history, which I tend to do. So, Wolf sprawled in front of his 65-inch TV. That's fantastic. Righto. So, MSF console QX use multi-handler set payload Windows. No, not Windows. CLR Meterpreter reverse TCP set lhost to, what are we at, 192. Oop. Oh no, that's very annoying. That's what happens when you don't have numlock enabled. Console QX use multi handler set payload CLR Meterpreter reverse TCP set lhost 192.168.146.128 set L port. I don't even remember what we had. It's probably 4444, right? Can you enlarge the font like you probably can, actually. In fact, you know what I should do is to make this consistent. Just a minute. Let me just boost the font size. Where is it? Sans regular. Let's make this a little bit bigger. Is that better? Did that make a difference? I don't think it did. Profiles default. Here we go. This is what we want. There we go. How's that? Is that big enough? Hello, DeRaven. Welcome. Thank you. All right. So here's what I'm going to do. I'm going to vim local.rc, and here we're going to go use. So you know what I'm going to do? I'm going to go set g lhost 192.168.146.128 set g l port 4444 and then we're going to go use payload CLR Meterpreter. No, we don't need to use payload. That's when we're generating exes, which we're not even at. We're going to use multi. I can't type again. Handler set payload CLR Meterpreter reverse TCP. We've got lhost and lport already set, so we're going to go set exit on session false and run -j, and then we'll go jobs -v. So then we should be able to go MSF console qr local.rc, and that should just spin it up for us, and then we can keep that for future reference. Hey Vendetta, thanks for coming in, mate. Always a pleasure. Okay, so now if we go back to our VM. Cheer shed roars, oh my god, Barney, stop it. Someone take his credit card away. It's killing him. Alright, so let's just rebuild our local solution, because we've got gotta make sure that we've got everything ready to go. Now, what I wanted to validate again here is you'll see we don't have any references in our test project pointing at standard API or metserve, right? So this means that in order to run this, we need to get it from the target. So 146.128.4444. Man, he's doing it again. I should ban him. You guys. All right, so let's just step into this and make sure that it's working. So once we've created this instance of met.core.server, which lives in the metserve server instance, you see we've got this bootstrap sitting here. All right, so I'm just going to run this and hopefully it'll break here. Yep. So the TCP client is a reference to the socket that's already talking to our target. And you can see we're just wiring in our TCP client instance and then we're invoking run. Now, first thing that we do is we set up our current transport and all that other stuff, and then we go into this packet dispatch loop, which is where I want to go first. Okay. So we have 5 here, and we'll see we should get a request off the wire, and the request looks like this. So we've got a few TLVs, and this should be the core negotiate TLV encryption thing, which we've already been through. But the second thing, second request, is the, as you can see, where is it? Core machine ID. And the third one should be enum ext command. So that's saying, tell me how many commands are wired in for this particular extension. And the extension that it's asking for is, where is it? Value standard string standard API. So you can see that standard API. So it's saying, what extension functions do you have wired in for standard API? And so responding to this should result in a certain handler being invoked. And here we can see we generate a list that's empty. See, we've got this response, and you'll see it's got just the request method and result, but it doesn't have any instances of strings saying these are the methods that we currently support. Okay, so it's returning an empty list. And as a result of that, our next message we should get is loadlib. Okay, so we're loading standard API here, right? So here's where our core loadlib handler gets invoked again. And you can see we create a response, we get the data out, and we call assembly.load. Now this is where it should work. It should actually work, so it should successfully load. But then when we try and actually deal with any types that are baked into the assembly, it's going to break. So as you can see here, we've got this exception. And if you have a look at the exception says, unable to load one or more of the requested types. And the loader exception says, we can't find metserv net35. Now, this is a problem because we know it's running. And if we look at the, where is the modules window? We look at the modules window, we can see this one here, this unknown and this unknown. These are the two that we've actually invoked ourselves using assembly.load, okay? Now, if you have a look at the symbol files here, you can see that there's a hint that we've got metserv loaded and we've got standard API loaded, but this one needs to be able to find this one. But as you can see, there's no name associated with it, so it's unable to resolve it. So here's what we're going to do. We're actually going to cheat to get around this problem. So for every single instance of an app domain, when it fails to resolve a type, an event will be fired. Okay, so what we need to be able to do is subscribe to that event. Okay, so when our plugin manager kicks off, what we're going to do is we're going to go app domain.current domain. So whatever the app domain is that we're currently running in, there's an event here called assembly resolve, right? There's a few other ones like domain unload and process exit, resource resolve, etc. But we're worried about assembly resolve. Okay. Now, assembly resolve gets fired, as you can see, when the resolution of an assembly fails. All right. So we are going to subscribe to that event because we want to know when something fails. Okay. So what I'm going to do is, I'm not going to call it current domain assembly resolve. I'm going to call it, I'll just call it assembly resolve. Okay. Now, what I'll do here is for now is I'm going to return null and set a breakpoint, and I'm going to build it again so that we deploy, and then I'm going to run it again, and hopefully we'll land here and we'll be able to have a look at this resolve event args. Okay, run, boom. So we can see assembly resolve has failed, and the arguments that are passed in say that we are looking for metserv.net35. Now, realistically, in the course of our processing, the only thing that we're really going to need to resolve is metserv. Everything else should not have any dependencies. So for the sake of this exercise, I'm literally going to do this. Return assembly dot get executing assembly. So that means whatever assembly we happen to be in, right? And that then should work. And that means that when we call this plugin type, we should actually be able to get access to whatever types are wired in, because we are basically saying, hey, you want a reference to metserv, I'm going to give you one. That's basically what this is doing here, right? So we know that the assembly resolve gets called when it's looking for metserv. So I'm returning a reference to metserv. That's what this is. Hopefully that makes sense. Does that make sense? Does anyone have any questions there? Is everybody too distracted by Barney dishing out way too many coins and stuff? By the way, welcome to a bunch more of you who have since appeared on stream. I can see you all in the chat, including the likes of Sysop. I can see you hiding. Thanks for coming in, boys and girls. Distracted by the rainbows. They are rather distracting, not gonna lie. All right, so let's set a breakpoint here so we can see that actually happen. I'm going to set another breakpoint at this plugin type doesn't equal null. So hopefully we should see something there. And then from there, we should actually see standard API wire itself in. Okay, so let's see it go. We can get rid of that breakpoint and that one. All right, here we go. So we're resolving metserv. Now, technically, we could put a string check in here, but I don't really want to hard code the word metserv in as a string anywhere unnecessary. So, ooh, yeah, I'm going to get the get system emote happening and all that sort of stuff as well. All right, so get executing assembly. That's assembly.get executing assembly gives us metserv net35, which is the one we want to return. Okay. So we hit F5, and as we can see, plugin type now has the standard API plugin, which means that that reference is no longer invalid. We can cast that instance to a plugin instance reference, and as you can see, it's not null, and we are now inside our standard API plugin code, and we are about to register a function by the name of core channel open, which basically just does nothing at the moment because that's just a stub function we haven't filled out yet. But as we can see, it's actually wiring things in properly. And there we go. We actually have a staged metserv and a staged standard API. That's pretty cool, I reckon. What do you guys reckon? Now, Meterpreter is sitting there running. Now, behind here, I'm pretty sure it's going, you know, things aren't working as we would expect. But let's see what happens when we just rerun this without any breakpoints. Looks like it's relatively happy. Now, it might actually eventually time out because it's still expecting more back and forth. But the good thing is clearly we've got to the point where we can load assemblies on the fly. We can resolve the plugins, which is effectively what the extension functionality is. So yeah, that's basically the go. Hey Eric, welcome to the stream as always, mate. Thanks for coming in. I thought you'd appreciate the this is fine burning background. So clearly I'm the only one that's excited about this, but that's okay. I'm pretty happy with that. So we have the need for this core channel open function, which we're going to start filling more of these out as we go. But channels in particular are a really tricky one to nail because there's a lot of underlying functionality that we need to bake in order to support the notion of channels. And so as a result of that, we're probably going to do that on another stream. But in the short term, we're going to start implementing some other bits and pieces. Now, what we need to do is when we register this function inside, when we register all the functions for a given plugin, right? what we need to return when we do this core load lib is we need to enumerate all of the extension commands for that plugin. Okay. So that means once we've registered this, so let's go back. Once we've registered the plugin, we need to basically go through and do what we do for core enum ext command, and we need to get the all of the TLVs, sorry, all of the registered commands for the thing that we've just created. Okay, so that means we do this. Okay, now extension name is plugin instance.name. So we can get all of the extension commands for the thing that we've just loaded, which we have just gone through the registration process of, and add each one of those as of type string to the response. And this means that Meterpreter on the flip side knows that the functions that are loaded into Meterpreter are available for use on the client side. Okay, so let's make sure that we can do that. Oops, stop, got to rebuild and then do it. Okay, so at this point we know we've only added one, right? So we should get core channel open, and then we return that as a response, and that should be sent back to Meterpreter, sorry. Now let's see what happens. It's going to ask for sysinfo and all that sort of stuff behind the scenes, but have a look at this. You can see it sees that standard API exists. We don't have all of these features yet, which is probably an issue that indicates that Metasploit is not correctly parsing those commands and responses, making sure that it filters out the features that are available. As we can see, it is actually doing what we want it to do. All right. Now what are we going to do? Where should we go from here? Let's just exit out of that. There's one thing that we should probably support, and that is core shutdown. Now this exception here is probably saying, hey, hang on, we're sitting here waiting for a byte or something to come off the socket, and so as a result of things being terminated, we're sitting there waiting and an exception is thrown because the socket's no longer valid. So this source array not being long enough, that's probably it attempting to parse a TLV when it really shouldn't be doing that. I like how playing a file is considered a standard API command. Yeah, no comment at Wolf. No comment there. Now, what I'm going to do, I think, is implement the core, I think it's core shutdown. That's basically what we should be doing. Now, core shutdown is... it's technically a core command. So we should probably do it in here. This dot, actually, you know what? We're going to do it as part of the server code. Packet dispatch loop. Have I done any registrations in here yet? I don't think I have. Nope, I have not. So once we get, just before we're going to run the dispatch loop, we should register the commands that are specific to the server. So I might put a helper function in here. Private void register server commands. We'll just call them server commands for now. So this dot plugin manager dot register function. We're going to string.empty. Actually, let's keep it consistent for now and just leave it as an empty string in that way. Now the method I think is core shutdown. Okay, and we're going to need to give it the name of the core shutdown handler. Right. Now, well, what else do we need to give it? There's another thing. Now, core shutdown, I believe, is blocking, so we need to set that to true. Okay. Private void core shut down. Nope, not void. Packet. Core shutdown packet request. Pretty sure that's what I need to do. Alright, so we're registering core shutdown as a function here, and we're saying that it's inline. And in just a minute, I'm going to make a couple of adjustments to this function. And the way that the packets are, the way that the handlers are invoked, because we need to be able to tell whether functionality, whether things should continue to run once they've been processed inline or not. Gotta have a standard core function, let the victim know you're connected. Right. Any questions? Make sure you sing out if you have any questions along the way. Now, let's actually change this now, because what we're going to need to do is we're going to have an enumeration somewhere along the line, and we might even put this in our high level sort of, actually, should we? We basically need to indicate whether we should continue processing or whether we should bail out. But we also want to be able to say, like, do we want to change transports? Do we want to exit the server? And do we want to do various other things? Looks like using string.empty and other register commands. Oh, am I? Well then, yes, that's right, I am. Good call. Let's be consistent. String.empty. All right, so let's just go back here for a minute. I'm going to change this function definition so that it makes use of a new enumeration. Okay, and I'm going to put it alongside the plugin manager because it's kind of plugin related because of the way that the function registrations happen. Inline processing. Result. Yeah, I think we should call it that because, and we don't care what the actual values are, so I'm not going to specify this as a particular enumeration. But what I'm going to say is, you just continue. We're going to have a change transport, or I should say, next transport, and shutdown. And then what's going to happen is, we're going to have a function that takes 2 packets and returns an inline processing result. Okay. Actually, you know what I'm going to do? I'm not going to do that. I'm going to say that the handler, we've actually got 2 types of handler. We've got an inline handler and we've got a non-inline handler. So maybe what we should do is change it so that the function definition has 2 different types of handlers. But I don't think that makes a lot of sense. So maybe what we should do is leave it as inline processing result. Inline processing result. And what we're actually going to do is when they're in line, we will look at that result and exit accordingly. If they're not in line, then the actual result of the functionality is going to be queued behind the scenes on whatever transport just happens to be in use. Now, something else has just happened. I just got a dingle in my ears. A new follower, which I am not going to be able to pronounce. TRIETPTMPWC. Thank you for the follow. Very kind of you. Okay, so from here on in, when we try and register these handlers and functions, we are going to have to pass in, we're going to have to return the result of processing. Now, and instead of generating a packet ourselves, we're actually going to have the calling functionality generate a response from the request and pass both of those things in. Okay? So this means that instead of invoke handler returning a packet, it's going to return an inline processing result, and it's going to get given the packet request and response. So this is going to behave in some ways very similar to how the Python interpreter works from memory. And instead of returning null, we're going to return continue. All right, so now inline processing result, packet response. So this will remove the need to call create response in every single one of our handlers as well. Okay. Return response, we're going to return inline processing result continue. Core enum ext command, same thing. Oops. Is this making sense to everyone? Return inline processing result continue. Okay, so that solves those problems. We're going to have to do the same for standard API. Let's just rebuild and we should see the errors magically appear. So core machine ID, same thing here. Inline processing results, packet response. And here we're going to go continue. Now, machine ID will actually not be inline. And once we've readjusted each one of these functions, what we'll do is for everything that's blocking, we will run inline and check the result. And for everything that's not blocking, we will just hard code the result of continue, and we'll spin off different threads for things to be able to return the results on the current transport. It's basically how that's going to work. Chat's gone dead. I'm going to eat some more chocolate. So we have some more viewers have come in the last 5 minutes. Greetings to everyone who's watching. Drafty Butt. Haven't seen you on stream for a while, mate. Thanks for coming in. Drafty Butt is a very old dev friend of mine. It's always a pleasure having him on board. I see you snooping. Hope all is well with you, buddy. We need to have a coffee soon, hey? Been too long. Can't beat a bit of dark. I agree, Smithix. That's true. The serial number is still hard-coding static. We are going to fix that. I promise. Okay. Let's go back and fix these other things. Core shutdown. So this is going to be a really, really easy implementation. So inline processing result, packet response. We are going to return inline shutdown. Okay, that's basically what that's going to do. We do also need to add a success result. We're just going to return that. But we're going to rely on the calling functionality to dispatch that packet for us in all of these cases. Yeah, no, it wasn't stream 2 or 3. We didn't even write code until like the 4th. This was only maybe 3 streams ago at Wolf. I'm going to say it was 10, maybe. We did a lot more groundwork before we got to that. Righto, so here's where we're going to work some magic. So response is going to be request.createResponse. And then we're going to go pass response in, and the result is what comes out. Okay, now we're always going to send the resulting packet. But what we should do, actually, maybe what we should do here is we're always going to be invoking this handler. Now I guess, when we try and create this, when we invoke this handler, what are we returning? We're returning continue. Maybe what we should do is put another one in here, processing result. We'll just say missing, is that what we're calling it? Not implemented. That's what we should do. So behind the scenes, instead of calling continue, we call not implemented. And then we will know here if if the result equals not implemented, then we're going to add that as a result. Ooh, do we even need to do that? We probably don't. We can do this here, can't we? And just call continue. So let's get rid of that not implemented nonsense. And we don't even need to check for it here. Okay, that makes a bit more sense. Yeah, I hear you, man. It's funny. It's hard to believe I've had nearly 2 full weeks off, but it was kind of good. I feel rejuvenated. So anyway, all right. So we get this result out of invoking the handler, and we do whatever it is that we're going to do, and what we should do as part of our handler invocation perhaps is, because once we got the result and we have a reference to the response, something needs to send that packet back, right? Now, what we need to make sure that we do is, in cases of threaded functionality, we need to make sure that the sending of the result is done on a separate thread. If not, it needs to be done on the current thread, right? So the question then becomes, who has the responsibility of sending the packet? And I'm wondering, see, the plugin manager should be handling the case where the packet is where are we again? I want to look at invoke handler. Okay, so for example, at this point here, if the function definition is blocking, then we want to do whatever it is in line, right? But if it's not blocking, we want to do it on a separate thread. So maybe what we need to do is go, let's have a think. That works perfectly fine. If it's not blocking, we want to create a separate thread and return inline processing result continue. We don't actually need to do that at this point. We just need to be able to spin off a separate thread. That needs to be in the else case. Don't know what happened there, but my editor went a bit funny. Okay, so this means that here we want to create a separate thread and do this fd dot handler. Okay. What I think I might do is this. Private. Yeah, actually, you know what? There's not enough functionality to require reuse, so I think I might just cheat. And we will go. We don't have tasks available to us because we're on .NET 3.5, right? Do we? Yeah, we don't. So threading, system.threading dot start thread start. Now, do we need to parameterize the thread start? No, we don't. No, that's not what we want to do. We need to create a new thread. That's what we need to do. Barney's cheering again. He's trying to get to the top of the leaderboard. Ah, Barney. New thread. Now, what we need to do, what I want to be able to do is create one from a delegate. oh, I should say from an action. So C# thread from action. It's basically what I want to be able to do. I can't remember how I did this. Parameterize thread start. Okay, so that's pretty much all I need to do. But I don't even need to do that, right? Okay. So let's go thread start equals new thread start. And we're going to have FD. Oh, this is what I should do. This makes way more sense. So new action that takes nothing. And we go fd.handler request. I had this magic idea just now where I could go, oh, you know, let's create an action that wraps it up, and then if it's blocking, we'll just invoke it inline. If it's non-blocking, we'll just do it as part of a thread start. But the problem is that the return types of those things may cause a problem. Anyway, let's see what happens. If we can create this action, request response, that's happening. So if it's blocking, we can just go, see, what I want to be able to do is have the function return, but because it's an action returns void. So that's not even going to behave. So thread start fd.handler request response. So we'll invoke this as part of, God, I really can't type tonight. Okay, and then we can go bar thread equals new thread and pass in thread start like so, and then we can just start the thread and that will then return continue. Now I think the one thing that I may change slightly here is the way that the handler is actually invoked, because I think it makes a lot of sense for once the handler has done its thing, that the plugin manager then invokes the sharing or the sending of the resulting packet out on the current transport, right? Which means we're going to need a reference to it at some point, which I don't think we have as part of the plugin manager. So maybe when we create a plugin manager, we don't have references to basically anything else. So one thing I guess that we could do when we create a plugin manager is pass in some kind of routine that dispatches a packet. We could do that. And the other option is to pass in a reference to the server, which you then say, please dispatch this on the current transport. Now, I personally prefer the idea of saying, right, I'm going to give you an action which takes a packet, and we're going to call it packet dispatcher. So that will allow us to sort of invoke the packet dispatcher. We can go this.packet dispatcher equals packet dispatcher, and we'll set that up as a property. Now what I might do is mark each one of these things as read only, because we don't want to create new ones of those as we go. And in doing this, we can basically say up here when we create our plugin manager, we'll pass in this .dispatch packet. Right? How do you spell dispatch? It is that, isn't it? Yep. Okay, now if we make this something that's private, we can go private void dispatch packet. Okay, and this is really just going to do one thing. This.currentTransport.send packet. Now this allows us to abstract to one level because we don't want to pass in a reference to the current transport because that may change over the course of processing. So we want to be able to dispatch the packet from inside the plugin manager when the handling of the functions has completed. Okay, so that means when we're doing this inline processing result, we want to go result equals that. We're going to return the result when it's done, but in the middle, we're going to dispatch this packet dispatcher response. So that will dispatch the response of what we got. And ultimately, we want to do the same thing as part of our thread start. So let's chuck this in here. We're kind of doing the same thing, but we don't care about the result. Right? Hopefully that makes sense. So we're doing the same thing in both cases. Here we do care about the inline result. Here we just don't care at all. So we just, return whatever. So this means that if the function is blocking, we will run it in line. So things like core shutdown should be in line, but pretty much everything else should be done asynchronous. Now, by calling this packet dispatcher potentially on separate threads, we do need to make sure that we have, like on our current transport, any kind of locking for sending and receiving, we should probably have something in place to do that. And this is going to open up a realm, particularly for TCP transports, which we hadn't handled before. And that is, we need to make sure that we can asynchronously handle reads and writes on the current socket. Does that make sense? Had another two followers, Summertime 57 and HDSX. Thank you for the follows, people. And Barney is going bonkers with his bits again. Far out. So what is he? He's currently at the top. That's what I think he was striving for. Stop throwing bits around now, Barney. You are done, my friend. You are all done. Now, we are in a slightly different realm here. Now, we should probably check to make sure that the TCP transport is thread safe. So if we have a TCP client in .NET, is it thread safe? Let's have a look. The read-write portions of TCP client are thread safe, as explained in the documentation for network stream class, which is what the TCP client uses for actual I/O. So this is a winner. So read and write operations go away. Read and write can be performed simultaneously on an instance of the network stream class without the need for synchronization, as long as there is one unique thread for the write operations and one for the read. That's fantastic. So all we need to do is make sure that in our current transport, what are you doing, Barney? No way, you're not my dad. So what are we doing here with our current transports, our TCP transport? When we send a packet, we're going to need to make sure that only one thread at a time can send packets. Now, for those of you who don't know, in .NET, there are a number of different synchronization primitives that we can use in order to synchronize across threads. One of them is a mutex. Now, that's probably the most common example is a mutex, but the problem with mutex is they're actually kernel objects and they're really heavy. We don't really want to have to transition in and out of kernel mode just to be able to support that. So we're not going to do that. So what we will do instead is use something called a monitor. Let me just quickly fix this. Inline processing results. Continue. Packet response. Now, because we're passing everything by reference here by default, the response packet, we don't need to pass like in and out or ref or anything like that. It should just magically work for us. Pardon me. So that should now build without errors. Now, It's been a while since I've used this, so we'll go C# example monitor. The monitor class system.threading. So here we go. You can see that we can create monitor.enter. Now, monitor.enter takes an object, which is effectively a lock object, right? And it's generally, I believe, considered bad practice to reference an object that's publicly usable. But let's have a look at the documentation for this, right? And you should probably have a try-catch around this sort of thing, I believe. Let's have a look at some other user monitor to enforce your synchronization. Lock this. That's a bad idea. By the way, don't lock this. You should have like an internal lock object. So what we will do is go private object lock object equals null. That should be null as well. We should probably initialize all of our stuff to null. Oops. Okay, and then when we create our base object, which is of type TCP transport, we should go this.lockObject equals new object. Now we don't really care what it is, as long as it's got its own reference that's internal. Okay. Actually, we should not call it lock object. We should call it TCP send lock. Let's call it that. Okay. I do. I have it on just one of them. Thank you, Wolf. So here we should be able to go lock this dot TCP send lock, and this is basically behind the scenes using a monitor, and it's making sure that we only allow one thread to write to the stream at a time. And because it's not a kernel object, we're not sort of transitioning in and out of from user mode to kernel mode to do the locking. It's actually done completely in user land, which should make things a little bit faster. In the native Meterpreter, we use mutexes everywhere, which is technically a little too expensive, or more expensive than it should be. But this at least means that we should be able to send stuff across all of our different threads and have things work appropriately. So what I'm going to do is I'm going to build this, and I'm going to see if it works. Now, actually what I should do before I continue doing that, let's just go back to the server. And I'm going to stick a breakpoint on the packet dispatch. There you go, dispatch packet. And while I'm also there, I'm going to go to the plugin manager, and let's have a look to see which things are invoked on threads and which are not. Okay, let's run. Right, so this we can see is being run on a thread, and the request is for machine ID. And that's sending a packet. What's going on here? Call load lib is on a separate thread. Everything seems to be behaving as expected. Is Metasploit unhappy? Call load lib request failed with the result dot. That's not good. Let's just have another look. So some of these things should be blocking. So here you can see we've got call load lib request failed with the result dot. So that kind of implies that there's something not quite right with the way that we are handling our packets. So let's have a quick look. Is that another follower? Hot Oreo, welcome to the following crew. Thank you very much. It's very kind of you. Okay, so the problem that we've got is only, by the looks of it, only one thing so far is blocking. And I think that's the shutdown. But everything else should result in this dispatcher being invoked. Let's just have a look. Packet dispatcher. This should be invoked behind the scenes on a separate thread. We just want to make sure that the result, what have we got here? So this is returning from core machine ID, which makes sense. This one is enum.ext command. As you can see, there's nothing in it. The next one should be a response to call loadlib. The question is, did it actually send? And one would assume that it did actually send, but the problem is this call loadlib request failed result dot. So maybe we've got something going wrong in call loadlib. No, it says packet result.success. That's what we would expect. Let's run again. What is this packet? Maybe I need to just force a rebuild. So that is the machine ID packet. This is the enum.ext TLV. But again, this packet, TLVs, we have one result. We do, what is that? Result, is the result not actually set? Value is set, type result, okay, 0, here we go. Count equals 0, value is 0. So that's fine. That should be returning success. And then here we can see we are adding the success result to core loadlib. So that should come back okay. And we're sending that packet out. But obviously it's not particularly happy. Let's stop doing breakpoints. It's definitely not happy, eh? So the thing about how this should work is that it doesn't matter what order the packets are sort of being sent in and out. There should be some kind of tallying up of requests that have gone out and responses that have come back. We don't actually have an ordering mechanism that makes sure that that packets are being sent out in the right order that they are created. And so at some point down the track, we're going to start adding sequence numbers to certain kinds of packets, or at least TLV packets in general, to make sure that things get reassembled on the Metasploit side appropriately. We should probably do it two-way as well, if that makes sense. So core loadlib request failed with result dot. I don't know why that's the case. So this is something that we're going to have to look into. But as you can see, here it says no response was received to the core loadlib request, whereas now we're getting core loadlib request failed with the result, and it can't find what the result is. So maybe there's something in that for us. Because core loadlib should be returning. Now, actually, here's an important thing to note. Maybe core loadlib needs to be non-blocking. Let's have a look. The standard API functions. Let's make sure that we are request core loadlib returns a D word. So it's not returning a Boolean. So that sort of implies that loadlib is not, there you go, it's a plain command REQ, so it's not inline. So we are doing the right thing by it. So it's not inline, so it should be able to return asynchronously and transmit the response asynchronously. So maybe we should have a look on the MSF side to see why it's thinking that the core loadlib request failed with the result. Blah. All right, let's vim some stuff. Metasploit framework. Now let's ag it, not grep it. Ag failed to load extension. It's going to be in here somewhere. Failed to load extension. Rex post, it'll be this one for shoresies. Failed to load extension. Okay, so that would be because of this use module name provided. Use the remote side, then load the client side. So client.core.use. So let's go ag def use in librex post. That's exactly what we're looking for. So let's open that up. Okay. So we should end up down in this load library call, right? Which means about to load the library. Okay. Library loaded. Commands are commands.inspect. Let's run that again, and we'll see what this spits out. I'm guessing it's not gonna get to this point. I think it's gonna throw an exception in here, which is why we're seeing what we're seeing. But let's have a play and see. Yep, there we go. Call lib request failed with the result blah. So it's definitely barfing in here. Load library. So packet create request. So that's where we're creating our outbound request. We're doing a bunch of if then else checks to make sure we assemble the packet more appropriately. And then here, transmit a request and wait for the default timeout seconds for a response. So let's go standard error.puts response from core load lib is response.inspect. So we should see a result come out, right? We should see a result come out. And if it doesn't come out, then there's something going on with the marrying up of the commands on the other side. Okay. Any questions so far? There's 30 people watching-ish, and nobody has any questions. Okay, so let's have a look at what we got. Request from core load lib is method core load lib UUID, but there's no result. Why is that? There is no result. So failed with the result, blah. It's clearly indicating that we have no result. Response.nil, no response. Result doesn't equal 0, core load lib request failed with, okay, so it's nil, which is rather fascinating. So in plugin manager, we are specifying the result to the adding it to the response. I wonder if I do need to make sure that when the packet's dispatched, it is actually getting what we would expect. Let's just quickly check again. We dispatch this packet. Maybe the packet length didn't get updated. No, I don't think that's... Oh, Buster. Buster B. Cook. Again, we're in the presence of greatness, ladies and gentlemen. It's nice to see you, Brent. I miss your face already, my friend. It was so nice hanging out with you over in Austin. I hope that it doesn't take as long for us to cross paths again in person. Hello, Domino9. So I think the problem here is that the packet that we're sending back as part of core load lib, which is not that one or that one, it's this one. Pardon me, packet result is success. So it is definitely in there. We've got the result being set. Value is 0. Let's actually watch this get serialized. Okay, so we create a new packet stream and a binary writer, and for each TLV, now this TLV is this dot type is request ID, so it's not that one. This type is method. This dot type is UUID. This dot type is string. Okay, that's fine because the string is going, what does the string contain? Val, core channel open. Oh, okay, so we're not in the same thread. Type result. Okay, so this, come on. Okay, so this TLV is a result TLV, which is, this is debugging thread sucks, doesn't it? So that looks like it's fine. But it's as if there is no result being written. So as far as the packet length, just to be clear, Brent, the packet length isn't written until the whole thing is serialized. So we just add collections of TLVs as just a data structure in memory, and then when we call to raw, we serialize the whole lot. So that includes whatever the length of the TLV data is, and that includes every single TLV that we've written. So, and we didn't have this problem before. So I'm keen to know why this is the case. Now, in our plugin manager, when we do call loadlib, response, T-speed transport, let's just raw packet. So that means that that one's there, the TLV negotiation, which is in line. Machine ID. What is this one? This is machine ID again. This one is enum ext cmd, which has request method and UUID. Ah, that doesn't have a result. That's interesting, isn't it? Enum ext. So that should be this one down here. Core. Okay, so that is also having it set. Maybe we need to change the way this result is being set. Response.result equals packet result.success. Let's do this instead. Maybe this is my problem. I think I abstracted this. Result. Are we doing it anywhere else? Packet result.success. Doing it here as well. Okay. And in the server, core shutdown. Okay. Let's see if this makes a difference. Is that just the same? It looks like it is. Server, plugin manager. Let's break here for a minute. Let's just go to the definition of this. So when we set it, oh, we're basically doing exactly the same thing anyway. We should only be setting that once for each, but you know, clearly our serialization is broken for some reason. So let's go back to our TCP transport. Right. And let's see. The response is TLV encryption. That is machine ID. Is that right? Response. enum ext cmd. This is rather interesting. I think maybe I might be wrong about something that I assumed earlier on. It looks like things are being passed by value and not by reference. So when we create this request, right, in our packet dispatch loop, we create this response, right? And then we call invoke handler and pass in the response. Now, session UUID. Ah, hello. We should do that and then not send that. That's a bit more obvious to me. You see what we did there? We had an overhanging send packet, which we shouldn't be doing. Oops. Okay, so we've got this result from the invoke handler, okay? And then we basically need to go, right, what are we going to do based on that result? So if we're going to shut down, we need to exit. So we want to go var running equals true. While running, we want to set running equals false and break. If we want to change to the next transport, then we need to do some other shenanigans. Otherwise, processing result continue, which is basically the same as default. We'll just do what we would normally do. Yeah, that invalid data is deliberate. I'll come back to that in just a second and explain why that's the case. Okay. So what we want to do here is actually change what the current transport is. Now I'm going to put a to do here to the next transport. So I'll probably have next transport and prev transport because you can go in both directions, but there's a little bit of a nuance here when it comes to transport because we need to make sure that the current transport is effectively torn down and then we go to the next one and we spin it back up. So this packet dispatch loop, you'll see we call packet dispatch loop here. So what we're going to need to do at some point is return. We'll probably need to return. Yeah, actually, you know what? That's probably what we need to do. Is we'll just leave that as while true, right? And we can say if the result is not continue. So if we're not continuing, we're going to return whatever the result is. Okay. And that result is inline processing result, which we may rename. Now what happens here is if we get it, if we for some reason have an issue, we should probably return inline processing result dot next transport. So if we're unable to read a packet off the transport, we should probably try to go to the next one. Hey, what's up, Coda Panda Bear? Thank you for joining in on the stream. And so what we need to do then here is like, we can go switch packet dispatch loop. So what happens? What happened here? So if we shut down, then this is where we need to effectively bail out. Cheap way would be to throw a, exception that says we're shutting down, and we don't have to care about it. But instead I'll, for now, just do the same thing that I was doing before. Running equals true, and while running, we'll do all of the things. But here we'll go running is false, and then we'll bail out. Otherwise, if we need to switch transports, I'll put the to-do here. And the case of inline processing result dot continue, which is the same as default for now, we'll just break, which at the moment effectively does nothing but move to the next transport. So in this case, I mean, we're not going to return continue. So it might make more sense for us to go, you know what, we shouldn't even be here if this is the case. But for now, I'm just going to leave this with a note. Remove this case. We might not even use a switch here, because the only two we're really interested in are these. Let's just say shutdown and transport modification. Now, in doing that, hopefully, we will not get the issues that we were seeing before. Oh. Hey. Okay, so standard API doesn't look like it's loaded, does it? It's like, for some reason, it didn't return the result. But let's have a quick look, and we'll see what happens with core loadlib. Where is it? Core loadlib. Here. We didn't get a core loadlib? Really? That makes no sense. Why are we getting no core loadlibs? What have we done? And by we, I mean you guys. What have you guys done? Something's going wrong. It's probably to do with the command dispatching that we've literally just modified. Packet dispatch loop. What are you saying sorry for, Brent? You don't need to say sorry. Okay, so let's just have a look. Let's start at the top. So create a response, we add the UUID. And then we invoke the handler. Call's not implemented, so that is the enum TLV thingamajiggy. Ooh, okay. We still, there you go, so there's a problem. We are not returning a result for the cases where the calls are not implemented, so we still need to do that. Now, if we'll probably need to just do this in line. So maybe what we should do is change this around a little bit. So if it's not blocking, we'll do it on a thread. And then Yeah, let's do that. So if we get the value and it's not blocking, let's just move this down here for a minute. So if not FD blocking, so if it's not blocking, then we'll do the thread related bits. Okay, and we'll return inline processing result continue. So we just carry on doing what we're doing, okay? Otherwise, if it's blocking, we just need to specify the result. Oops. Inline processing result. Let's even default to that so we don't even need to do this. And then we can go else result equals late to the party. What is this session about? Try to figure it out but lacking context. Okay, Coda Panda Bear, we are currently building a Meterpreter implementation that will run inside the CLR. So it's a full C#.NET implementation of the Meterpreter payload. That's what we're currently in the thick of. And at the moment we are just sorting out our threaded versus unthreaded packet dispatching, which is context and function specific. I'm just making sure that we are not shipping packets when we shouldn't be and that we are shipping packets back when we should be. And I'm trying to make this code at least semi-readable. In this particular case, I want to execute the dispatcher, but I don't want to dispatch the packet until here, right? Now the issue that I've got is when we have done this, I want to bail straight out. So what I may need to do is have an early out clause here. At the moment, no, it's not .NET Core, it's .NET Standard. The plan down the track will be to look to see which bits can be sort of moved into .NET Core so that we can have this invoked on anything that supports .NET Core, but for now it's just like .NET Framework, I should say, not .NET Standard. Hopefully that makes sense. So yeah, I'm gonna go inline pressing. So we want to early out here. You're welcome. Please keep the questions coming, mate. Happy to answer wherever possible. Okay, so we get the result and we do return that. When we invoke the handler, we do want to dispatch the packet. If it's not there, then we do want to... Okay, so this should be fine. So this means that we should at least always dispatch a response. So call load lib, we should actually get to here. Let's just make sure we haven't broken anything. Hang on. Rebuild. How are we doing for time? We're approaching 9:30. Okay, so we create a response, and then we invoke the handler. And the handler says, do we have something? No, we don't. And then we want to dispatch the packet. That makes much more sense. We return the result to the caller, and it's like if it's not continue, then bail out. Otherwise, continue. So, do we have a happier session now? Here we go. Look at that. That's what I'm talking about. So we actually have the result in there now. That makes way more sense. Response from core load lib is that packet with core channel open as the option. Library loaded commands are core load lib. That's much better. Okay, so there we go. We can actually start interacting with things now. That's a win. Happy with that. that I'm very much happy with. Now let's see if our shutdown command works. Ooh, no. Let's see what happens when we shut down. Server. Now shutdown is an inline result, right? So let's see what happens when we do that. So plugin manager, no, server, core shutdown. Okay, so let us go to where are core shutdown. Oh, why have I got invalid data? We need this. Sorry. So who was that? That was Gonathu saying you had response.result is invalid data instead of success. I assume this is what you were referring to, and you were indeed correct. Sorry, I thought you were talking about another case, but you are indeed correct. That's exactly what it should have been. So let's rebuild that. Yep. Sorry about that, buddy. Thank you very much for the heads up. My bad. All right, so we're going to let that run. Come on, talk to me, VMware. Let's see what happens here. See, we didn't even get there, do we? So you're hosting a server on Windows machine to which Meterpreter communicates with. No. So on our Linux host, which is our attacker machine, this is effectively what the, I guess you could say it's client server, but in almost two directions. But the attacker machine is the thing that Meterpreter is talking to, and you have different ways of actually establishing that communication. Meterpreter is the agent that's running on the machine that you've just owned, and so it's the agent that you can use to perform actions on the target. And I would refer to that more as a client than a server. So the server is the attacker machine, and the client is on the target's machine. I did. Let's have a look. So invalid data should be right with core load lib. Command handler machine ID, so that should be success as well. Okay, there you go. Two cases that I did it wrong. Yeah, exactly that. Exactly that. So we have we do have an RPC where the attacker machine is controlling the agent on the victim machine, and we do have a full duplex communications channel. At the moment, it's just over TCP. We'll be adding other transports such as HTTP and hopefully down the track DNS at the same time. Good questions. Okay, so SignalR. Well, let's what we got to remember is that I would assume, Panda Bear, that you haven't seen the previous set of streams. So the beauty of this project is that we have a history that we need to maintain. So we are talking to Metasploit, and Metasploit talks over HTTP, HTTPS, TCP. It's currently kind of sort of works with the DNS. We're still working on that. But we have our own protocol, and we are looking to work various new transports in. Now, SignalR, correct me if I'm wrong, that's just an abstraction over things like WebSockets and long polling and all that sort of thing. So you can have a SignalR server, and your web client, or possibly maybe message queues or something, will sort of tap into that. But SignalR is the abstraction, right? So what we're doing is we're providing implementations for this equivalent abstraction. So we wouldn't be able to use SignalR. We have our own SignalR in some ways. Hopefully that makes a little bit of sense, yeah. So Meterpreter's transports and communication protocols were established in 2004. So we are still living with those, and it suits its purpose. But I will say that one thing I would like to see eventually is a WebSocket transport for this. So it will be more SignalR-like as time goes by. But feel free to implement that for me. That'd be awesome. WebSocket transports, I think, would fly under the radar of a lot of firewalls / proxies, etc. I think that would work really well. Okay, so we have a problemo in that core shutdown. We need to make sure that we're actually getting core shutdown coming through. So let's just have a quick check of that. Righto, let's just look at watch. We're going to go request. Oh, we've got request method up already. So this is what we're looking at. We've got request TLB encryption, machine ID, load lib, getuid, which we haven't implemented yet, but that'd be an easy one to implement, I would say. Been having fun with MQTT and WebSockets, so pity anyone implement. Yeah, exactly. It's going to be terrible. Okay, let's see what happens when we type exit here. Core shutdown. Okay, so we get that. We invoke the handler, and the handler should not. Ooh, what do you mean call not implemented? Core shutdown. Did we not register core shutdown? Oh, we didn't even invoke this. Wow, that was dumsies. Who can I blame? Register server commands. I'm going to blame Arroway. He's just turned up. Let's blame him. Welcome, Arroway. Good to see you, mate. Could be down to find the time for it. Trying to fix my own requirements list for several branches of auth and the same. Yeah, right. Fair enough. Okay, this should hopefully do what we want it to do now. Let's go and call sessions -1 exit. Look at that. It actually works. Oh, and it even closed down. Look at that. Just like a bought one. Sessions -1 exit. And it stops. Wow. It's actually doing some things that I would expect it to do. Who would have thought that it was possible? Any questions so far? Does what we're doing currently make sense? I think it's fairly intuitive what we've done this evening. So I'm at the point where I'm thinking, you know, that could be a good logical break and we can work on some more functionality down the track. But there is one thing that we can probably do. We've got enough time to add one more thing, don't we, hey? Is it closing down transport sockets down cleanly on both sides? Well, that's a very good question. Let's see. Let's see what happens at this point. Because I would argue no. I love how that got disposed, even though it shouldn't have been. But let's have a gander. I'm going to go with no, because we're not actually invoking it. So that would mean that when we bail, whatever transports we have at the end of processing, so where are we? Run. Okay, so when we bail out, we need to go through and we need to go for each transports. And then we can go, even though we don't need to do this. See what happens now. Now this is interesting to me. Why are we getting a dispose? Oh, it's because we're wrapping. Yep, that makes perfect sense. Okay. Exit. Here we go. Let's close down our streams. There we go. Look at that. We're actually clearing stuff out properly now. gRPC. I'm not familiar with gRPC. Should have a look. Righto. Now, yes, we need to, later on, I think maybe on our next stream, we'll handle this timeout exception because we want to make sure that if the session actually times out, that we clean up and bugger off. Therefore, what I'd like to do, excuse me, is in our plugin manager where we have this not implemented call. I know the first one we're going to get when we do this is the request is going to be the TLB encryption, which I'm not implementing just yet. But the second one, what is that? It's a standard API one, isn't it? Config getuid. So let's implement that as a thing. So we're not going to do core channel open. I think actually, for some reason, core channel open exists in standard API in the native meter, but I don't necessarily feel it belongs there. But I'm going to leave it there for now. Let's go manager.register function, this.name, and it's going to be standard API. Oh, geez, what was it? Config. I've forgotten already. I'm a goose. Config getuid. Let's copy that value. We'll stop that. There we go. Config getuid. We know it's going to be false, and we'll go this dot sysconfig. In fact, we can start breaking these things up into separate bits of functionality, but for now, I'm just going to leave it as sysconfig getuid. Alrighty. Now we will move this stuff around. Sysconfig, oops. Sysconfig getuid. Now let's just have a quick look at how the native Meterpreter makes this happen. Standard API, sysconfig getuid. Invoke Meterp. Let's have a look at the C code. What? What? This makes no sense. It's got to be in the native one as well, otherwise... There it is, standard API. This just makes no sense why the GitHub search didn't make it appear. Okay, so the implementation thereof is just here. What is the unregister going to be used for? So unregister will be used for a point where we can actually unload plugins. It does get implemented in some of the other Meterpreters as well, and I do plan to implement support for that properly. Populate a UID. So what does that do? Okay, let's have a look. Get the UID of the current process/thread. This is a helper function that does the grunt work for getting the user details, which is used in a few other locations. That's true. I remember adding that comment. But now, what's really important is that we've got this get user token. So we should have a look at that function because getting that token gives us the SID. So it gives us a token for the current, I would assume, thread or process, and then we get the SID associated with the token, right? And that will give us the name. See how when we call lookup account SID, we can get domain and user, and that's what we use when we return the response, right? So let's just have a quick look at what get user token does. Righto, we've got open thread token for the current thread, and we open the process token for the current process. So we try and get the current threads token, and if that doesn't work, we get the current processes token, and then we try and get token information for that and return the actual token as a result. So let's see if there is a .NET equivalent. Let's have a look. 2000.net. Customer reported open thread token was failing, access denied. I want the equivalent thereof, so see, we don't want to use pinvoke. There's got to be something in the .NET framework which would allow us to query the token for the current thread, right? We don't want to pinvoke. That's what we're going to avoid doing. So it's probably easier just to look directly on the current thread object, right? So sysconfig getuid. If we went thread, which is in threading, current. Okay, so we've got current thread, which gives us a reference to the thread that we're currently running on. And there's this current principal. Gets or sets the thread's current principal for role-based security. So I'm wondering if the current principal is the thing that we want to query. So there's an identity object that hangs off that, and that should have a name, which is a string. All right, so let's just have a look at this for a minute. Let's see what this does. You see how easy we can register functions with callbacks now? It's pretty cool. Did we actually build this? We shouldn't have call not implemented for that sysconfig getuid now. Here we go. All right, so X is blank. Current principal identity is blank. So that's not what we're looking for. So maybe what we need is thread.get current, current thread. Let's have a look at that. Excuse me. Let's have a look. Thread state, priority name, manage thread ID, current culture. So maybe what we should do, yeah, so, okay, so Panda, just to be clear, this is an important implementation detail, because when we start impersonating other users on certain threads, we need to make sure that this getuid knows to reference who we're actually currently impersonating. Ryan Roberts, Cubs lover, sup? How are you, man? Thank you for joining in on stream. So I'm thinking that that's not what we're looking for. So if the current identity, yeah, so again, because during the course of the lifetime of Meterpreter, a current thread, yeah, so again, so Windows identity.getCurrent.token, does that associate with the process token, the thread token? Does one take priority over the other? And if we call getSystem and we extract a system token and apply it to the current thread, will the Windows identity.getCurrent.token reference the system token, or will it still reference the token that the process was created with? So this is the kind of thing that we're going to have to think about. All of these things, yeah, exactly. Exactly. Someone did say getSys. I knew that was coming. I should have shut my mouth, shouldn't I? I'm doing fantastic, Ryan. Thank you. How are you, mate? Current context. What does that give me? Context properties. This is something we're probably going to have to research. So, so the thing is, I thought Windows Identity was not part of 3, but I guess it is. So, okay, so let's go get current dot. Is there a name associated with that? We just reference the token. Let's see what happens here. So maybe this is basically where I do need to live. Drafty, you might at least have pointed us in the right direction with dealing with Windows identity directly. So let's have a gander. Fail train / that's exactly what I'm looking for in the current context, which is pretty cool. All right, just anxious and imposter syndrome. Yeah, I think I know the feeling, man. It makes me wonder why, you know, 30 people like to sit here and watch me fail repeatedly on stream, but you know, they seem to dig it. Okay, so for the sake of this exercise, I'm going to go with Drafty Butts current thing. I'm not going to reference the token, I'm just going to get the name because it seems to have exactly what we're looking for. And we'll deal with the impersonation concerns down the track. So we'll go response.add. Now we need to give it TLV type dot something. I don't know what that is yet. Let's quickly check in. Where is it? It was in here somewhere, wasn't it? Get user token. Get SID, which we'll deal with another time. Populate UUID. Type user name. How counterintuitive. Ah, it's not even there. Righto, so now we need to go and add that because that's part of standard API. Standard API stuff. Let's go dig that up. Whoops. Nearly done, and we're coming close to the end of our time. Now, where is it? I want to grab the C version because that's going to be the most extensive. Meterpreter development, yes, yes, still doing it, my friend. I know that made you unhappy last time. Here we go. Yeah, well, I'm majoring in computer science, just nervous so I can make it out. I'm sure you'll be fine, mate. All right, let's add the sysconfig TLVs. I'd rather be doing something hard with a great, amazing reward than something easy. Yep, I would agree with that. Any reason you don't have the standard API plugin update the TLV type list when it's loaded? Well, how do I do that? Wormir, I promise we will have binary stuff again. I'm not just going to live in this land. As I said at the start of the stream, we are going to do at least 2 per month where we're going to do non-CLR Meterpreter development stuff. So bear with me. I'm trying to construct stuff to make people's pen testing lives better / easier, while also servicing other people's desires to see, you know, various hacking relating activities. So I appreciate your patience. So Outwolf, in order to update the TLV type list, like this is a fixed list at compile time. And at the end of the day, it kind of doesn't matter if we add another chunk of enumeration bits and pieces here, right? So what I need to do is put a base constant somewhere. So let's do this, because the standard API, you can see how we start with standard API as the base, and the base for standard API is 0, so that's kind of pointless. Yeah, fixed to compile time, because type systems, yo. So we'll go standard API username is going to be, actually, you know what we should do is standard API, I'm going to call it standard API plugin equals, because we have a base according to this of 0, which doesn't really make a lot of sense. And you'll see we use this as a base. So we've got this make custom TLV, and make custom TLV is defined in common, which would be here, common.h, pretty sure it's in here, make, maybe it's not, custom TLV. Where's the definition? Where are you? Come on. Text main, railgun, network plug, audio, Kiwi main, wimpy mem, unhook and core. There it is. Right, so make custom. You've got meta, base, and action. You see it's just added together and ORed with the meta tag. So we don't do any tricky shifting or anything like that. But what I'm going to do is I'm going to set this to 0U. And then, as ugly as that looks, we're going to have standard API, sysconfig. Oh no, we don't need sysconfig username. We can just have standard API username because that's what this thing was. Where was it? Username. There you go, TLV type username. So we'll just have standard API username. And we can see that that is a string with 1042 next to it. Meta type dot string 1048. Oh, what am I doing? You. Okay. Now what we should probably make a habit of to make it consistent with everything else is standard API plugin plus, because then if the base of this actually changes, then it should be fine. One thing I encountered in the past would have been to download standard API, parse in the dictionary, and then use the enum and check that dictionary. Yeah. Yep, I agree with that. Was it 1042? Did I fat finger? Yeah, it was. There we go. All right, so that means TLV type, I'm gonna call it standard API username. And then we'll see if the sysinfo stuff actually coughs that up. So we don't need to add any more. Oh, actually what we do need to do is go response.result equals success. And return continue. And this will be the last thing that we do for tonight. Okay, so we've got our response and hopefully everything gets wired up nicely on this end. So we can't see anything listed here. We don't have getuid listed. Why don't we have getuid listed? File system networking. So getuid should behind the scenes just invoke exactly the same functionality, right? So config getuid. Yeah, so standard API sysconfig getuid. So that should be there because we actually returned that. Core load, library loaded commands are core load lib. Okay, so this is wrong. We are returning core load lib when in response to this. Oh, here we go. Standard API sysconfig getuid is returned as a result of that. So library loaded commands are core load lib. So there's something up. So core load lib is coming out from method, and we're looking at that instead of looking at the strings. So let's just quickly library loaded client core library loaded. Yeah, this is interesting, hey. So why is it that core load lib is being returned as a list when it shouldn't be? Because load library should be returning a list of commands that comes back out. So let's just see what's going on. Ooh, response that each type method. There's our problem. This should make things wire up a little better. All right, let's go. That's better. Loaded commands. Standard API says configure your own core channel open. So they were loaded as part of standard API. Oops. Sessions -1. Get UID is now present. Boom, there we go. Server username, failtrain OJ. Excellent. So that works. Does that make sense, everyone? It's another little bug that we've since fixed, which is good news. All right, so just to recap, we fixed up our library loading because now we're sort of dynamically returning a reference to the assembly the metserv lives in. And for the sake, I think, of our needs, we can probably just leave it like that. And then down the track, if we find cases where we're unable to resolve assemblies that we don't have, then maybe we'll put some other checking in place so that, whatever name is being resolved does actually match the one that we should be providing. So with that in place, we did some more rejigging of how we register, invoke, etc. our commands as they come in. So now instead of having each command generate its own response, we generate the response from the request, then we invoke the handler, and the handler returns whether or not that thing should result in the server stopping processing and all that sort of stuff. And we also support threaded versus non-threaded commands. So I think, in our last couple of hours, we've actually bashed out some decent functionality. To be honest, that went a little bit better than I was expecting, particularly given we've had a couple of weeks off. So from here, I think, we can start implementing other commands. I'm going to probably put a to-do in... Where are we? I might put a to-do in here. Validate that this works correctly when we impersonate other users or use get system. There you go, I've said it again. So we just want to make sure that this Windows identity.getCurrent.name actually does match that which we have impersonated. Thanks very much, Coda Pandavera. Appreciate you coming along and asking the interesting questions. Hopefully, I hope to see you next time. Thanks, man. So there you go. If you have any questions, as always, jump in Discord, send me a tweet, drop a comment in the various internets. I will do my best to get back to you and answer and all that sort of stuff. And as always, thank you for coming and supporting. And Barney, if you're still there, stop throwing money at people, including me, in particular me. But yeah, I'm really glad you guys came along. Hopefully you got something out of it. It's good to make a bit of progress again. And with that, I think I might sign off. So be good to each other. You know what it's like out there. People are jerks. Oh, I've got another follower. Thank you for the follow, Furzback, I think. But yeah, lovely to have you all on stream, and hope to see you again in a couple of days. In the meantime, look after yourselves and keep drinking that tea. It's good for you, because hacking without tea is very uncivilized. All right. Good night all. Take care.